test?
I did better than I thought I would.
I was mad.
Oh yeah.
I got like a B minus, but I don't know what I got wrong. I can't find it. I'm gonna text her or message her.
Okay,
I went through it like twice.
do you want to do the assignment first, or do you just want to divide out the project first?
Oh yeah, I forgot we have to do that tonight. Um, we can do the project first if you want.
It could just be easy. Like I could be.
So what do we have to do tonight? We have to.
I think just sign out. Who's doing what?
I could do the PowerPoint.
Okay.
And take action.
I could do step 1. What do you want to do?
I can do 4. And then I guess we could do 3 together. Cause you got 5 and 6.
Mhm.
So then we'll take care of 1, 3, and 4, and then 2 and 7 we all do together.
Yeah.
So who needs to submit it?
I do.
Okay.
Where do we submit it at?
I don't know. Submit this document with the name filled in above. I'm guessing just email it to her.
That's what I'd do.
Okay, so number 1 is going to be Cambria. And I think so. For describing the data, that's going to be me, not, yeah.
Yeah.
Making inferences, kind of the same thing. I can do that one. Taking action, you're doing that one?
Yeah, and 6.
6 is your 2. Maybe I'll put Canberra on mine.
Okay.
Yeah. So I'll email that to her after we get done. Okay, so go to the group work now.
Yeah, 6 and 7 are just creating graphs. You guys know how to do those?
Yeah. Oh, go to Excel, right? You don't have to do it on the making inference one, do you? Phew!
What?
Oh, that sucks. Um, did you do this one already, number 6?
Yeah.
So they want you to create it for the class rank. Is it talking about credits?
Yeah.
So you just highlighted both of them
Hmm.
all the way down. Um, Mine looks a lot different than that. Did you highlight the very top of it?
I don't think so. I don't know. Mine might be wrong.
Did yours look like the one on the answers?
Let me check. Oh, no, it doesn't.
What does yours look like?
Like crazy.
Was it that totally multicolored one that's at 1%?
Yeah.
So, can you split it up by age? Same. Because on here it's split up freshman, junior, sophomore, senior, but is it in the data?
Okay. Okay. I'm just kind of confused at what it wants.
Because in Handshake, you see how it's based off of like freshman, junior, sophomore, senior, and in the data it shows that.
Create a pie chart. The classwork. So I think is it just asking for how many of each?
So that would be just the ranked column, not the credits, not the rank. And there's like one that
Are you figuring it out at all?
Yeah, sorry, I like just was able to pull up SPSS. I had to connect to the VM software.
I mean, sophomores.
sophomores or something.
Oh, 2 years. Is there one more coming?
I don't know who he is. And
Okay, I figured it out on Excel.
Okay, I figured it out on SPSS.
Well, I kind of figured it out on Excel. I don't know if that's the right way to do it.
but he got the advanced.
I don't know if there's a simpler way to do it, I should say.
Mm-hmm.
Okay. So,
And create a bar graph. This one.
Okay. Did you get that one to work too?
Mm, yes.
Okay, so use at least 5 descriptors to create the data above.
From the box, well, yeah, the bar graph, it looks like the data is kind of right skewed. Or would that be left skewed? It's skewed somehow.
Yeah, a little bit. But that was in
order.
for freshmen to sophomore and stuff.
Yeah.
You sure?
Look, freshman, junior, sophomore, senior. Oh, freshman, sophomore, junior, senior. Not this.
Well,
So yeah, it's not in order.
what it is, mine. Yeah, mine.
Yeah, yours is in order.
I don't. Do we use skewed on this one?
I don't know. I didn't read anything saying you didn't.
I don't think you use skewed as much on the bar graphs, just because you can move them around.
Yeah, true.
I was thinking it's just like scattered, like really inconsistent.
Yeah, and the longer in years you have in school, the higher your rating.
What's a frequency table? Did we read about that?
Probably. I read this a while ago, so.
I don't remember reading about a frequency table.
Yeah, I don't think that's in here.
Well, it just seems like there's more. I don't know, it's hard to say. There's sophomores that have the most, then juniors and seniors and freshmen have the least. I wish I knew what it was talking about.
Yeah.
All right.
And
Yeah. 7%. Yeah, go ahead.
Oh, no, you're fine.
7% is a true unknown percent of the population do not have traditional phones and instead rely on cell phones. 7% is P. Suppose a random sample of 750 telephone users is obtained. What is the probability that more than 60 phone users, or 8% in the survey, use only cell phones? Okay.
So wouldn't the mean be 7%?
Yeah. I would think so.
Yeah, because I think the end of the reading it said the mean is the same as P.
Yeah. So then, state the problem in terms of a variable. So then it would be.
Well, we gotta find the standard deviation. Where do we get the standard deviation from?
Oh, I skipped that.
Isn't it?
Isn't it x over n?
It's that P times 1 minus P on the square root, and then that's divided by n. So 0.08 times 1 minus 0.0, or is it 0.07? No, I think it's 0.08. We'll see. How many samples were taken?
700.
So, yeah, I don't think this is going to be right. What's the answer?
0.009.
That's right. No. Okay. So you put 0.08, you put all under square root, 0.08 times 1 minus 0.08 divided by 750.
Okay. So that's 0.0099.
Yeah.
Okay. So state the problem in terms of the variable. So are we saying that p is greater than? Yeah. So we're trying to find what the probability of it being greater than. So it'll be 60 over 750, correct?
Yeah.
Let me check the answer key. Yes, it is. Again, with the, we're supposed to draw a picture and shade the desired area. So I'm guessing it would just be a normal bell curve. We're saying that it's more, so then it would be the right side that'd be shaded.
Yeah.
Okay.
So in the z-score formula is the value minus the mean divided by the standard deviation. I didn't get that answer.
Why is it 0.01?
0.08 minus 0.07. Wouldn't you go 0.08 minus 0.07? I keep getting 0.10101, but the answer key says 1.073.
So the value, so it's the value minus the mean, right?
Yeah.
750 minus 60 divided by... That's a very big number. Okay, well I did the 0.08 minus 0.07 over 0.0099, and I just got 1.010.
That's what I did. That's what I got too.
So P, we're looking for C, right? This is the
Yeah.
equation I just. So P times the 1 minus P.
That's the bottom half.
I know, but it
You already figured that out. Let me try something else.
that doesn't make
Wait,
it. Just take moment.
this, guys.
Oh, then go to the end.
Okay. 0, 3.
0, 0. Exactly.
Closer.
Close, yeah.
That's not how you do it then. I'm confused.
Me too. Maybe they have the answer wrong.
That's what I always wonder. You never know.
So we're putting in the numbers that they have right above there.
Okay, what does it mean by standardize the values?
I don't know. Convert the standardized values.
From looking at the reading, it sounds like we're doing things right.
I know, that's what I'm all at a loss for.
doesn't make sense to me. Like, the way you're doing it makes sense, so I don't understand how it gets off. Last time Chase tried, he got like 1.075 instead of 1.073. That's really close, so why would it be off just that much?
Well, because I'm confused, because in the reading, I thought to find the standard deviation, you took the proposed mean. All these p hats and p, they need to find a different variable. See, what we did to find that answer for the standard deviation was we took the square root of 0.08 times 0.08, excuse me, 1 minus 0.08. And divided that by 750. No? What did I do wrong? Oh, that's what I did wrong. Yeah, but in the reading, it says to find the standard deviation. I'm looking on 3.3.1. It's talking about if you the probability of doing heads is 0.68. But on the bottom, and it has a z-score equals the value minus the mean, so 0.68 minus 0.5 divided by the standard deviation, which is 0.1. So I went back and I plugged in 0.07 for the standard deviation. And it gives you 0.0093.
Yeah.
So when I went 0.01 divided by 0.0093, I got 1.075. I don't know. I feel like we're doing it. I feel like with the formula, right? I just don't know. Because I get how to do E, I get how to do F, but I don't know what we're doing wrong in this one.
Neither. Let's see. I wonder if they did do it as a typo. Like, do you have the probability app open?
I'm getting it right now. What's the z-score?
1.073.
Yeah, the area. Oh, I guess it is just the right side. No, that's the same. That's the same answer.
mean, I don't know what we're doing wrong.
I know. Kind of annoying.
I'm gonna call a kid real quick.
Okay.
I've taken his class too. I feel like we're doing it right, so I think we should just go on.
Yeah.
I honestly, I don't know.
Everything else makes sense. I mean,
Yeah.
the only thing that doesn't make sense is how we're getting the wrong answer. So, in interpreting the area, there is 0.1416. Like, that's the chance, right?
Yeah.
That there would be 60 phone users that only use their cell phone.
Mhm.
Okay. Are you ready to take the quiz?
You guys ready?
Yep. So for 3, okay. In a pie chart, why are the slices sectors different sizes? Pie charts are more visually appealing when the slices are different sizes. Each slice represents a category, and the area of each slice represents the proportion of the total occupied by the category. The size of each slice is random, or the size of each slice is determined by the number of categories. I think it's B.
Yeah.
Yeah, me too.
Okay.
How are bar charts and Pareto charts related? They are identical. Pareto charts are constructed from tossing a coin several times. The only difference between a bar chart and a Pareto chart is that bars in a Pareto chart are ordered largest to smallest, going from left to right.
It's
C.
C.
Yeah.
Okay.
We conclude that the P is normally distributed if NP is greater than or equal to 10 and N is 1 minus P is greater than or equal to 10. So is P the true proportion or the sample proportion? I think it's the sample.
Yeah, me too.
See, I'm confused about this.
Mhm.
Look at this. Look at the difference in the P's.
I know.
Right here. The
Oh,
mean
and
of
then the random variable. It says random variable is P right there, too.
sample proportion. Right here. Sample proportion P with the top
Mhm.
is normally distributed. N is large. The true population mean of the random variable. The random variable being P with the hat. Mean of P with the hat equals P. So the standard deviation of P with the hat is P. I don't know. This one's confusing me because I feel like it's the true proportion.
But it doesn't ever say true proportion.
But look at what it's talking about, though. The p hat. Sample proportion p hat is normally distributed and as large as the true population mean of the random variable p hat is
But
the true population mean.
True population, not true proportion.
Cam, look.
Chill.
Sample proportion.
I get it.
Which is talking about p hat.
Okay, got it.
So how could
Okay, whatever. Just put true then.
you can put whatever you want? I'm putting true proportion.
And what is n? Then n would be the sample size, right?
Yeah. I think it's 40.
Okay, how'd you get that?
So you got to do n times p. It's got to be greater than or equal to 10, and n times 1 minus p has got to be greater than or equal to 10. So n times or p is 0.25. Then so 0.25 times 40 is 10.
Okay.
39 is 9.75. And then if you do the other formula, 1 minus 0.25 would be 0.75 times that by 40, it's 30. So it satisfies both of them.
Okay.
Use the following information to answer the questions 8 and 9. Suppose n equals 24 and p equals 0.4. What is the mean of p? Shouldn't it be 0.4?
Yeah.
What is the standard deviation?
Okay, I got 0.01.
What's the sample size? What'd you say you got?
0.01?
You got 0.01?
Yeah.
I got 0.1. So it's,
let's see. This is what I did. I did 0.4 times 1 minus 0.4 divided by 24.
did you do the square root of it?
Oh, no, I didn't. So it would be 0.1.
Yeah. Use the following information to answer questions 10 through 13. Brittany's batting average is .300. We want to determine the probability she will get more than 35 hits in her next 100 at-bats. What is P hat? P hat.
0.3. Right?
Should be .35. Yeah.
Because it says n equals 100 and p equals 0.3.
Yep. It'd be 0.35.
Okay.
2 decimal places.
No, because
Right?
if you round that up, it'd be 0.4. So to find p hat, you take the random variable, or 35, divided by 100.
Okay. Then,
So the standard deviation
Stop it.
I think, should be 0.046. I think.
do you say 0.046?
Yeah, is that what you got?
Yeah.
Where's that stupid z-score?
Okay, so
Where's the standard deviation?
0.2%.
Tell me what you get for the z-score.
Okay. Okay, I got 1.087.
That's what I got too.
Wait. And then for 13.139.
0.139?
139, yeah. 0.139. You got it right?
I think so. Yeah, I was just reading something.
Okay. So are you ready for 14?
Yeah.
Okay. If the true proportion of people who support a political candidate is p equals 0.52, and if n equals 2,000 people are surveyed, we want to determine the probability that the results of the survey will suggest the candidate is losing the election, getting less than 50% of the votes. What is the standard deviation of p hat? Okay, so how do you say that p hat?
P hat is in this case it should be less than 50%. So on question 10, p hat is because you're trying to find what the probability is that she will get more than 35 hits.
Mhm.
So you use 35 divided by 100 to get 0.35. The standard deviation of. So this one I think it's just it should be 50. The standard deviation I got is 0.011.
What'd you say you got?
0.011?
Yeah, me too.
Let me know what z-score you get.
Did you put it in as a negative?
Don't know.
I got 3.64.
3.64?
Yeah.
I got 1.818.
How'd you get that one?
It's 0.5 minus 0.52 divided by the square root, or excuse me, not the square root, divided by standard deviation of 0.011.
Okay. And it's 1.818.
Yeah, but you think we should put a negative on there?
Yeah, probably.
I don't get what 16's asking.
I looked it up.
I'm guessing it would be because we're trying to say that what we're calculating, the z-score is less than the one that's already calculated. Or it's saying that we're getting less than 50%. I don't know if that makes sense.
So what do you think it is?
I think that's the second one. It says that we want to determine the probability that the results of the survey will suggest the candidate is losing the election or getting less than 50%. So that's why I chose the less than. But
That makes sense.
I'm confused. I don't get what this last one's asking.
Me neither. I'm trying to figure out if it's like the 0.48 to make it a total of 1.
Because this last questions 11, 12, and 13 in the reading are confusing me. What is the probability the survey results will show the candidate is losing, even though the true Oh, is it just asking? Would it be 0.035?
How'd you get the 0.035?
Just because that's what's on the probability applet. To the left of that z-score is 0.035.
Then maybe.
But then, I don't know, on 11, 12, and 13 the reading are confusing me.
Yeah.
I don't get where they're getting this 0.72. I don't get where they're getting that number from. They just kind of pulled it out of their hat. Unless they did. I don't know.
Did you say 11, 12?
Yeah, because it's saying use the z-score computing question 11 to find the probability that the proportion of success will be greater than 0.44. So they just type in
Well, I submitted it, and the only one we got wrong was 15.
Was 15?
Yeah.
So the 17 was right. The .035 is right.
Yeah. And then 16 is the second answer. Like we said. So.
We're in a meeting, bud.
Hold on just a second, dude.
We're almost done.
Okay. Well, I guess we'll see you Thursday.
Yep, 7:30.
Okay.
Okay, thanks, Megan.
Bye.
Bye.